All right. Thank you for joining once again. As I was saying, we have a full agenda today, and we're going to be covering topics including the uh, Apache Apex core, Malhara, and applications, DataTorrent RTS platform and console, real-time dashboards and widgets, which will include demo of both console and widgets. And then we'll jump into more technical topics about Apache Apex autometrics, historical metrics with App Data Tracker, App Data Framework, snapshot and dimensions, data sources, and exporting packages and dashboards. I'll save some time at the end for Q&A, and I'll try to take pauses between a couple of sections, including after the introduction to Apache Apex, probably after the demo, and throughout the technical part of the presentation. So let's get started. All right. So first of all, some background on what is Apache Apex platform. It's a platform in a runtime engine, which enables development of scalable and fault-tolerant big data applications. It was originally developed at DataTorrent, and it was later introduced as an incubating project to the Apache Software Foundation. Last year, we became a top-level project, which was very exciting. And now it's one of the best ways to build your real-time stream processing as well as batch data applications. Some of the benefits of using Apache Apex include the extreme scalability. We've demonstrated being able to process over billions of events per second with real-time data sources, and scale linearly by adding additional Hadoop nodes. The platform is highly performant, and some of our customer use cases included requirements for millisecond latencies, which we were able to deliver, doing entire DAG processing in several milliseconds end to end. The platform is highly fault tolerant. It will automatically recover from failures without you having to take action. It also creates periodic checkpoints to support the fault-tolerant behavior. It's Yarn native, which means that it runs directly on one of your Hadoop distributions. It supports all the available distributions, including Hortonworks, Cloudera, MapR, AWS, and others. And it's developer-friendly because it exposes an easy API for developing components of your big data applications, including the operators, which can be written directly in Java code. And there's a large library of open source operators and connectors, which we call Apex Malhar. So let's take a look at what is available in the Malhar operator library. We have a number of input and output connectors, including being able to read from file systems, databases, NoSQL stores, messaging systems, and a variety of other data sources. Also, we have built-in operators for pattern matching, statistics, parsers, query and scripting, processing social media events, and a number of other things. So if we take a look at the DataTorrent platform stack, you'll notice that at the bottom we have the Hadoop cluster on which the Apache Apex runs, and the core platform and Malhar operator library represent the runtime of the platform. On top of it, we've provided a library of application templates which can be used to kickstart your development efforts. And on top of all this, so all the items below the box highlighted DataTorrent are in the open source. And the items inside the box are the ones that are offered as part of our enterprise RTS offering, which include the graphical application assembly tool, the console, which we'll be looking at for managing and monitoring applications, and the real-time dashboards and visualizations, which we'll be covering in just a moment. So let's take a look at some of the Apex and RTS use cases. Typically, what we see is customers will have data sources, such as Kafka, Amazon S3 perhaps, databases, social media feeds, or files sitting on HDFS. They'll typically want to access them, and they will do that by connecting with one of our connectors I mentioned earlier, which is available in the Malhara library. Then the application will process the data through the DataTorrent platform, which is, as you can see, it's a part of the streaming computation box here. The applications run, as I mentioned earlier, natively on Hadoop Yarn and are checkpointed to HDFS, and we support all the major distribution and clouds. And then typically, at the end of the computation, we can either look at the analytics and visualizations of streaming applications and write the output to various data targets, such as, again, writing, for example, events to Hadoop HDFS or various other stores listed here, such as Hive, Cassandra, MongoDB, S3, and others. And we have operators to help you make all this development very easy. So speaking of application development, let's take a look at what one of these applications looks like and introduce you to some basic terminology for Apache Apex applications. The applications are composed of operators, which you see represented here as boxes. So one of them would be input, parser, counter, and console. Those all represent application operators. Operators is where you put your custom business logic, or you can use one of the existing Malhara library operators. And the operators are connected by streams, which is how the data is sent from an operator to operator, which each stream represents a sequence of data tuples, which are the events that we're streaming and processing. And we typically refer to this entire application as a DAG, which stands for Directed Acyclic Graph. And it's basically made up of various connected operators and streams. The operators which have no input ports and only output ports we typically refer to as input operators, because they connect directly to one of the data sources to read the data. And operators which have input ports but no output ports are typically output operators, because they're connecting directly to one of the downstream data sources and writing the process information. And all the other are just general operators for processing that are in between. So if we take a look at the example below here, it's a Java application. It's one of the simple demo applications that's available in our examples library. And it represents a way that a developer will go about building the application. It basically starts with a class definition for application, which implements streaming application, followed by populate DAG, which is the application DAG, the Directed Acyclic Graph, and where you basically declare adding various operators. And as you can see, when you say DAG.add operator, you name the operator input, and that's what shows up here in a DAG above. And you add a specific class instance, which is going to execute inside that operator. After you've declared all of your operators, you connect them with the streams, and you also get to name the streams. So the first stream connecting input and parser is called lines, and you can see that the lines stream is connecting the line reader output port to the parser input port. So that's a basic summary, high-level view of how the applications are constructed. Now, when the applications are launched, they execute live on the Hadoop cluster. So let's take a look at how the running application topology is executed. Typically, if you're using Apache Apex directly, you will launch it with Apache Apex CLI, which is a command line tool, which allows you to launch your applications. Alternatively, if you're running the DataTorrent RTS distribution, you can use the DT console, which we'll take a look at shortly, to connect to the gateway, which is another part of the DataTorrent RTS system, which then requests, it actually uses Apex CLI, and then it requests the resource manager. And here the resource manager is the Yarn resource manager, to schedule and execute the application on the live Hadoop cluster. So the gray boxes below represent a single node where the resource manager has the local node managers running for every one of the application containers. So in this case, we have an application which has 6 containers deployed. And you can see that the resource manager schedules the containers randomly across the Hadoop cluster. So if you look at the numbers, we have number 1, 2, 3, 4, 5, and 6. As you can see, the numbers represent the operators, and the green boxes are the containers. So here is an example of one of the containers which has 2 operators, which means it's deployed in either a node local or a stream local format. And this is to avoid taking more expensive trips across the network between nodes. And other containers and operators, they all have other containers all have single operator within them. So typically how the data is processed through such an application, you can see the blue line here. The data comes into the input operator 1, and in this case we have another input operator 2, which is receiving the data. Then the streams converge and go to operator 3. The data then flows to operators 4 and 5, and 4 is connected directly to 6, which produces the output. So that's what deployed topology might look like. Also, one thing to note here is the main coordinator for these applications is the Yarn app master, which we've customized for Apex purposes, and we call it the streaming app masters, or short for STRAM. So we'll refer to it sometimes, and you'll see that this special this special container is typically labeled in our UI. So you can see you can look at it and view its logs and see how it's performing its tasks for scheduling other containers. Another thing of interest is when the applications are running. So if you look at the previous screen, we're looking at a simple DAG, which is linear and has one logical operator connected by stream, and it goes to the next operator and goes to the next operator. So this is the logical DAG, that representation that we see here. We have operators 0, 1, and 2. But as I mentioned earlier, Apex can automatically scale up your applications, and it does so by partitioning the operators. And here's an example of what partitioning might look like. So if we look at the logical DAG, we have a direct graph from 1 to 2 to 3. But if we look at the physical DAG view, where the operator 1 has been partitioned, and in the Hadoop cluster, this would be represented probably by multiple different containers on different nodes for operator 1. What happens is that the parts of the stream go from operator 0 to various partitions of operator 1. Then the data comes into another container, typically another operator, which we call the unifier, before it moves on to operator 2. So this is what partitioning looks like, and this is how we're able to achieve very high scalability in when running applications at scale. Next, let's go over the demonstration of the DataTorrent RTS console. We'll cover main features such as the App Hub, development section, monitoring, visualize, and configure. So let's take a look at the demo. Hopefully the demo cluster is cooperating with us. All right. So this is the DataTorrent RTS console. When you get to the console, you're looking at first at the welcome page, which is in the Learn section. And the things of interest to note here are the tiles, including running demos, discovering RTS, and creating applications, which are actually links. If you open one of them, it's a link to the docs.datatorrent.com documentation website, where you will find the relevant content for each section. And if we look at the top navigation menu here, we will see that the items are configure, which is where you can configure your RTS installation. This is also where you would go to configure security settings, manage user permissions, and also enable various services, and also enable alerts for the DataTorrent RTS console. The develop section is where you would go to manage your application packages. You would also find that you can view applications. You can see their details and logical DAGs in the section. And there's a visual application assembly tool which is provided. And you can develop applications not only using Java, but also visually in the develop section. In the monitoring sections, where you find running applications, or what we call application instances, where you can monitor and visualize the application metrics, events, and browse the application logs. Visualize section is where we would go to create real-time dashboards, which is the main topic of our conversation today, and look at the various widgets and data visualizations which are coming from our streaming apps. And finally, the App Hub is a location where you'd find templates and demos for the Apache Apex applications that are hosted by DataTorrent. So let me just pause and check if we have any questions. I noticed that some people are not able to hear me. Can a few people confirm that they're able to hear what I'm saying right now? Okay, great. Thank you. Excellent. Do you have any questions so far before we jump into the demo about the Apache Apex platform? Okay, let's move on. Okay. So let's jump in and start with the App Hub. So this is an exciting feature because when people first start developing Apex applications, they may be overwhelmed. The platform offers a lot of capabilities, and there could be some intricacies to developing your applications. When you go to the App Hub, you can find all the DataTorrent demos and templates hosted here, and it can be a really good starting point for kicking off your development project. For example, if you're considering streaming events from a Kafka message bus and processing them and then writing them to HDFS, you might want to start with one of the templates named Kafka to HDFS sync app. This is just a starting point, which will help you read the events from Kafka and just directly write them to HDFS. But then you can start building on this template and add your own custom logic in between to process the events before they're written to HDFS. So if you'll notice that each App Hub package has the application name, version, description, tags, and a button to import. If you wanted to import one of the packages, you can simply click the import button, and the notification will be shown when the package is imported. As you can see here, we've imported Kafka to HDFS application. You can also search for applications here. Let's say you're looking for only Kafka-based applications. You can see them here. Alternatively, there's also a list view which is provided, where you can easily filter across specific topics such as tags or required versions or descriptions for convenience. If we click on one of these applications, we're taken to the application summary view, where you'll see the name and the version, of course, but then you'll see an expanded description of the app, which explains in more detail what it does. Typically, we try to provide a few videos to help you jumpstart the application. There's also explanations of what the logical plan of the application looks like in this case, some of the launch properties you may want to configure. And for those of you developing this application template into your own application, the resource will be of interest, because you can also find additional information about each application, as well as you can see, for all the templates and demos, we provided GitHub URLs, where you can go find the source code for the application, which would be a good starting point for your project. When one of these applications is imported, as we've seen earlier, they are then placed in the local gateways HDFS storage location inside the application packages area. So let's take a look at the development section and look at the application packages. So here we see all the applications that have been either uploaded through the upload interface after you may have compiled an application locally and uploaded it, or the ones that have been imported from the App Hub. And here we're in the application list view, but if you prefer, in some cases, some packages have multiple apps, like here the various applications are from the Dimensions demo package. So you can also choose to flip to the package view, which presents each package as a tile with its name, description, as well as grouped list of applications which belong inside that package. So let's take a look at one of these apps. Let's pick a simple one, which is one of our demo apps. The PyDemo application that you see here is designed to calculate the value of pi, and we typically use it in some of the simple examples because it shows you one of the input or random generation operators followed by computation followed by a simple output. So what you'll notice in this view, this application summary view, you'll see the application name, its type, and as I mentioned earlier, the applications are typically developed in Java, but we also support JSON applications, and I'll show one of those to you in a moment. You'll then see controls for the application where you can configure application packages or launch applications. There's a application DAG, which represents the logic of the app, and various package properties which are configured and packaged with your app, which will be used during launch. When launching an application, you can always, if you're launching an app, you can always override the application settings by using custom launch properties and specifying the properties here. But if you don't want to manually override the properties every time, we've provided in our latest release, we have a new feature that's available, which is called configuration packages. So let's take a look at that. What you can do is you can configure this PyDemo by saying configure and creating new configuration. It prompts you to enter the configuration name, and if the name is not unique, it will warn you. So, for example, PyDemo Sasha has already been created. So let's create a new configuration name. When you create a configuration, you'll be notified that the configuration has been created, and you're provided with a link to take you to that configuration. What you see here is almost the same type of view, with the key difference being that you can actually see the optional properties available, which can be saved. So, for example, let's say that we wanted to, let's say that in our application, we felt that there's not enough memory being allocated to all the operators. What we could do is we could take the the package properties here, copy the name of the property for the operator memory settings, and instead of using 256 megabytes as specified in package properties here, we can configure it to be 512. After we're done adding the custom overrides, we simply save this configuration, and then we can launch the configuration. When the configuration is launched, so let's try launching this application here. It will be launched with the updated settings. So that's one of the new features, which is configuration packages. And looks like that application has been launched. And now let's also take a look at the JSON applications that I mentioned earlier. As you can see, most are of type Java here, which is a typical way to develop apps. But DataTorrent RTS console supports a JSON development format. So let's look at a similar application, which is a Py demo, but which is written in JSON format. As you can see here, the type for the application is JSON, and in addition to showing you all the similar package properties and logical DAG, there's also an edit button, which will take you to our graphical assembly tool. Here you have a listing of all the operators that are included with the Py demo app package. And you can choose to take any one of these operators and drag it into the application canvas. You can also rename them. You can change their settings, attributes, and ports, and you can connect the operators by using the stream feature. As you notice, when I select this new operator's alerts port, the compatible ports will actually glow in slightly fade in and out in green. So you know that it is compatible with this console operator. Of course, two streams cannot overlap, so you need to first disconnect the PyCalc from the console to connect it. But this is how you would go about connecting your operators and your streams, and renaming the operators and changing their attributes and properties. And of course, just like you can launch applications from that are built in Java, you can construct new applications from scratch in the graphical application assembly tool and launch them here. So let's try, and it looks like it wants to first save and validate the DAG, because when we develop applications, we typically compile them, and there's some validation provided at that time. But with graphical assembly, you first need to run the validation on the gateway, which is confirmed that the application is built correctly and is valid, and now we can launch it. So this is an example of how we can manage and launch applications in the development section. So next, let's take a look at the monitor section, which is where we see the running apps. And we've already launched a few of them. So as you can see, the application that we've just launched, the PyJSON demo, has been accepted. But let's take a look first at the operation summary view. There's a cluster overview, which is available at the top of the monitor section, which gives you all the metrics and performance indicators about your cluster as a whole, which represents all your running applications. You're able to see the CPU and cores utilized, the currently allocated memory and peak allocated memory, as well as all the number of instances of applications that are running, and you can see the ones that have failed, been killed, or submitted. You also see important information about how many yarn containers have been allocated and how many operators are running on those containers. And there's an aggregate number for the current tuples that are being processed every second. In this case, we're processing about 2 to 3 million tuples per second in the currently running apps. Let's take a look at one of these apps. So the application instances are listed in the view below here. And if you click on the link to application instance, you're taken to the monitor space for that particular running app. Again, just like in the cluster summary view, you have the application summary view, which gives you key metrics about this running application. So the really useful things would be to note the state of it. It will be in pending state when it's being launched, and it's in running state when everything is running. And then eventually it will go into either killed, stopped states. Also, you can see here we see the current window ID indicators, which can be really useful for during development and troubleshooting of applications to know which window is currently being processed. We see various latency, tuples processed metrics, and also total number of tuples that's been processed by this application so far. Next to the application name are some of the key controls, including being able to shut down or kill this application, change its logging levels, link to visualize and view the app master logs. If we look at the right-hand side, we will see that the applications typically have various events from STRAM, which is the streaming app master I mentioned earlier, listed in this pane. All the events such as starting containers will have similar color. Let's take a look at another application which may have additional STRAM events, and if it does not, we can certainly let's see. Yeah, looks like these are all have been started and they haven't had any issues so far. So what we can do is we can go to one of our apps. We can look at the physical view and actually kill one of the containers. When the containers are killed, the kill event will be shown in the STRAM events, and you will see that there's a exit status 105. You can click on the details to see additional details. Looks like in this case the container was killed by the application master, which is correct because I requested the container to be killed, and the application master delegated that task. And you can see immediately afterwards that this the operator which was running in this container is recovering automatically and is being allocated to a new container. So this is really useful when the STRAM events are really useful when monitoring and managing your apps, because you can see all the events, all the key events that are happening with your apps, all in one view. Let's go back to this telecom demo application. Next, we will look at the logical DAG feature. So in this case, we're looking at a fairly large app, which so far we've been looking at simple applications with only a few operators. But here's an example of an app which has multiple operators. As you can see, the operators are represented by boxes here. We have some metrics on these boxes, above and below. The metrics above represent the process tuples per second, and the ones on the bottom represent emitted tuples per second. You can change these metrics to show other statistics, such as, for example, latency or total CPU utilized, and you can see these metrics are changing. Let's go back to processed. Also, if the DAG in this case is very large, you can use this small map to sort of navigate by dragging this field around. You can quickly browse around your DAG. You can also click and drag the DAG here in the logical DAG view to move it around. And if you use the Option or Alt key and scroll, you can zoom in and out to get a better perspective on your entire application. Another interesting feature that I want to highlight that's available in the DAG view is we have something called the critical path viewer, which is available. If you select the critical path view, you'll notice that a path within the application is now selected in red. This represents the longest path within the application in terms of the delay for tuples processing, and it can be used to highlight performance bottlenecks in your application. So if you see that you have a complex app and you always see the critical path staying in one place, and particularly if you look at like latency indicators or the current window ID or other indicators that indicate to you that something is being delayed, this is a very good way to troubleshoot performance hotspots and improve certain operators to get more performance out of your application. In this case, you see that the critical path is jumping from one path to another because this application is fairly optimized. The delays are very low, and the millisecond latency it's currently experiencing can switch from one operator to another based on very small factors such as network or CPU utilization of a particular node. But that indicates that it's a fairly healthy application where there's not any major performance bottlenecks. Also, another useful feature on the logical DAG, if we look at one of the operators, you can actually click on the operator itself and be taken to the logical operator view, which gives you the summary of the logical operator. Again, it gives you its state and its own metrics, as well as the partitions. It shows the partitions where this operator is deployed, and gives you various. It shows you operator properties, and in some cases gives you ability to change those properties in real time. So the system is fairly dynamic and can be configured at runtime using the console. Below the logical DAG view, we have a logical operators table, which is basically the summary of what you see in the logical DAG view, just represented in a tabular format with all the metrics, statuses, process indicators, and others listed below. And below that, you will find streams, and also after the streams, metrics. So this is the monitoring section, logical tab. But as you can see, there are multiple other tabs. So let's take a brief look at a couple of others. If we click on physical tab, which we've gone to earlier to take certain actions, you'll notice that you can actually see the physical operators. So these are the deployed logical operators on containers, which may or may not be partitioned into multiple instances. They'll be listed below here. You also see details such as the host that they're deployed on, the container that they're deployed on. You can access, if you go to the specific container, you'll be able to access their logs. And another interesting feature that we have here is if you select one of these operators, you can actually record some sample tuples. So this is a really neat functionality that allows you to sample the data that's being processed through your application in real time. So let's take a look at that. Right now I'm selecting the input operator, which should only have data that's being generated and sent out on one port. If I click record sample, I see that is correct. There's one output port, and we see that there's some tuples that have been loaded. We can select the tuples here and actually see the data that's being sent inside the app. We can either browse through the tuples like this, or we can select using Shift and click, select multiple tuples at once, and scroll through the view. Another feature available is a filter where you can actually search for particular tuples and for the data inside those tuples, and the results will be highlighted. So this is really, really useful whenever you're developing your applications and you want to see what the data looks like coming in or going out to a particular operator, or you're in a production situation and something may be happening, you're not sure what's going on. You can not only see the operator metrics and all their behavior and their logs, but you can actually sample the data inside the applications. So this is a really nice feature. Below, in the physical tab, we see containers list, which shows us the allocated containers, and you're able to manage and kill selected containers and perform other tasks. There's other tabs, including the physical DAG view, which is the same as logical DAG view, except it represents the physically deployed operators. And here the operators and the various containers therein are highlighted with the operator outline in different color. So here the ingest customer service data is in one color, and enrich is in another, and the compute KPIs is in a different color. So now let's take a look at a visualize section, which is how you can view the application data and see it in real time, visualized in real-time dashboards and widgets. There are two ways to access it. You can go directly to visualize section and choose one of the pre-configured dashboards, such as the telecom operators dashboard here for the application telecom demo v2. Or you can go back to the monitoring section, choose one of the applications. Let's look at this telecom demo v2, and then use the visualize dropdown. It will show you the available application dashboards here as well. So it's a quick, convenient way to jump into the visualizations. So let's take a look at one of these apps, the visualizations. Here, as the data is loading, we're looking at the telecom operations dashboard. While the widgets are being populated, we may be having some network delays with our development cluster. We can take a look at some of the functionalities that are here. The Add Widget button allows you to select widgets and add them to this dashboard. The auto-generate can create new dashboard layouts for you automatically without you having to manually add a bunch of widgets for your application data sources. You can copy this dashboard, download it as a JSON file, which is convenient for storing and later uploading it possibly to a different RTS installation. And you can change the dashboard settings. So let me see here, because it looks like there could be several things happening. I could have been disconnected from my cluster. Okay, looks like we're back in business. So the telecom operations application is the logic of it is to take streams from call centers and call data records for a telecommunications provider, do processing and various dimensional computations, aggregate those streams, and generate insights and analytics, as well as store the results on HDFS. In this case, the useful widgets may include things like the number of service calls to a call center. In this case, this is a trend indication widget, which shows you that the number of calls is going up to this particular provider. And you see other useful information such as disconnected calls, current wait times. You see statistics about the disconnected metrics. You see information about the types of calls that are coming in, whether they're about roaming, billing, or other issues. You see distributions of devices for this telecom operator, such as the phones and the various phone model types and the bandwidth that they're utilizing. And you see the information about the regional information using our geo widgets to visualize the regions where you have disconnects. It's showing the zip codes and the number of disconnects by a zip code highlighted on the choropleth here, and also the average wait times represented by the circles widget here, where quite a few people seem to be waiting. There's each circle represents the amount of wait time in terms of its size, and they're geographically located on specific points on the map. Now let's take a look at what kind of widgets are available for us to visualize our data applications. So for this application, we have a number of data sources that are available. Depending on the data source, you may have different types of widgets that are compatible with that data source. So in this case, we have the store services key performance indicators data source. And the widgets compatible with it, we have table, line chart, stacked area chart, multi-bar chart, node, trend, single value, and JSON nodes, JSON debug widget. Another data source may have different widgets available. And here we have multi-bar charts, single value indicators, pie charts, gauge, horizontal bar charts, and other widgets. Also, if we take a look at one of the data sources providing geographic information, we can see that there's the GeoCircles map, which we saw earlier, the choropleth, along with other more regular visualizations for the data. Let's take a look at what can be done with some of these widgets and this dashboard. I mean, first of all, let's try adding a couple of widgets. Let's see if we can add stacked area chart maybe and multi-bar chart. You can add multiple widgets at the same time by selecting one or more widgets here and clicking Add Widget. The widgets are dropped at the bottom. So now, before we saw that the last widgets were map widgets, but now we're seeing stacked area chart and multi-bar chart widgets have been added to the visualization. You can resize the widgets. You can rearrange them. You can pick them up and move them around. So the dashboard is very flexible in terms of what it allows you to do. And for example, here, if we want to change the position of one widget and the other, we can simply replace them. If we do not want to, let's say that in this case we do not want to save these changes, you can simply reload the screen again without pressing the Save Changes button, and the original dashboard will be reloaded. However, if we do want to persist changes, we just need to click Save All Changes, and the dashboard will be saved. Every widget has a ability to customize and edit the widget settings. Let's take a look at disconnected calls. If we edit the disconnected calls widget, notice now that when the disconnected calls are going down, which is probably disconnected calls is probably a bad event. And when they're going down, when you have fewer disconnected calls for a telecom provider, it's probably a good thing. But right now, it's showing it in red color. So let's see if we can change that. Here we can find color options, and we can look at the upward trend indicator, which is green. So let's change that to red, and downward trend indicator, which was red, and let's change it to green. So now we flipped it. Another feature is to format the widget, and if you noticed, it was formatting with 2 decimal places. We can make it into a whole number by changing the format to 0 decimal places. So now when we save it, we see that there's no longer .00, and that the trend is showing correctly. When the disconnects are going up, we're actually seeing a red color as opposed to the green color we were seeing earlier. The bullet chart widget can also be customized. For example, the threshold here is set to 23. We can customize the threshold by changing it. Instead of, let's say we change the range to be 22, and when it hits that point, the average wait time of 22 minutes, I guess, will make it orange. And let's say that we want another threshold, which is, let's say, hit at 25. At this point, we really do want to go into red. If we save this, we'll notice that the wait time currently is 22, which is exactly at the threshold. So the bar is represented in orange. If it drops below 22, it will be blue. If it exceeds the maximum threshold, it will be red. So that's one of the customizations for the bullet chart. For line chart, we can select or unselect various metrics that are being displayed, and the charts will adjust accordingly. But if we wanted to, we can actually change the settings for how the chart is being loaded and what time scales, for example, are being used. So let's say that in the current time selection, we're showing you the last 10 intervals of the application window. So what we want to do is, let's say, increase instead of and here they're 1 minute windows. So let's say instead of showing last 10 minutes, we want to show last 20 minutes on this widget. We can simply say OK. It will reload and it will display last 20 minutes from 36 until 10:56. Also, for widgets that support various types of queries, you can choose which metrics are being streamed back. So here we have several aggregates that are being selected, including a disconnect, sum, and count. We can actually remove some of these and just have a single metric shown. When we update it, we see that there are no longer multiple metrics being displayed, and in fact, multiple metrics are no longer being loaded from the backend, so that can optimize the performance as well. If you have heavy visualizations, but you do not need to display all of the data, you can optimize performance this way. Let's take a look at the bar chart. Some of the features available. For example, you can change the sort order. So here we're looking at the various phone devices on a network and the bandwidth that they're utilizing. So let's say that we wanted to sort it in order of the bandwidth. We could change the sort order, and we can say download bytes. Let's have it in descending order. Click OK. We see that the top phone for this telecom operator is iPhone 6, followed by other phone varieties. Similar with the map widgets, there are a lot of customizations available. For example, let's customize the average service wait time by region. So what we might be able to do is, let's take a look at this. What we can do here is to customize. Obviously, for map, the time range is problematic because the only thing we have is a single flat display of a given point in time. But we can control in this map, for example, dimensional query selections that are being rendered. Right now, all the zip codes and all the regions are being displayed. But let's say that I want to select only a specific region. I can simply select it here and add it by clicking drop down and tab to complete. So let's say I only want to display region 93. If we click OK, we should see fewer. Yep, there's fewer circles being displayed now. So we're not loading all the regions. That's one of the ways that you can change the dimensional display for your widgets. Let's also change this visualization to. Let's change this visualization to change the map styles. For example, currently the circle color is red. We can set it to, let's say, a color green. We can change things like even customize it as far as land color. Let's try to make it brown, and background color, which on this map represents water. We can make it blue. So the widgets are fully customizable. We can also change the visualization in terms of what is displayed from the perspective of the map. So right now we're looking at the California map, but let's take a look at map of the United States, where the states are highlighted. So here we have map of the United States, and we're seeing the circles being shown here. We can scroll in and out to zoom in and out of our map, and we can get better view of our data as it's coming in. As you can see, when you hover over particular points on the map, you see the average wait times. So this is a good introduction to the real-time dashboards and widgets that are available in DataTorrent RTS. And of course, as I mentioned earlier, you can save all your changes, and you can also download these dashboards by hitting download, and you'll get the dashboard downloaded as a JSON file. If we open this file, we'll see that for one of these dashboards, all the information is stored inside. So this is what one of these dashboards looks like internally. And if you look at the details, you'll see that you have all information captured here, including the name, the state of all the widgets, all their positions, all the data, the query configurations, and everything else. So let's see. At this point, I'd like to go back to the presentation, and I'm going to pause before I get to the next section to answer any questions that people may have. Okay, so going through some of the questions that I have, how do we scale out? Does each instance retain state? The scaling is done based on the data that's being, so scaling out, I'm assuming you're talking about like resizing partitions either statically or dynamically for running application. If, for example, the volume of data goes from, like, let's say hundreds, which can be processed by a single node, to millions, the scaling out can be done dynamically by an operator by partitioning the input stream and making multiple copies of the same operator and deploying them to different yarn containers across your Hadoop cluster. As long as you have resources available, we can scale out linearly. And then if it's a single operator being scaled out and there's a DAG that needs to converge behind it, we also have multiple cascading unifiers. So you don't try to bring, for example, hundreds of operators into a single, unify them into a single operator. You can actually do it gradually by, for example, unifying 10 at a time into groups, and then unifying those groups of 10 into smaller groups. So that's how the scaling out is done by the platform. Also, let's see, scaling down, that is also done dynamically. If you can change the operators to scale up and down dynamically based on the workload or various other metrics. We do have demos available for telecom. Demo for telecom operations, where you can actually ask the demo to increase the flow of events being generated. You will see that the application is scaling up and down dynamically when that is requested. So let's see, other question. Okay, question on dashboards. Is there a mechanism to publish them to external users, or is the dashboard confined RTS such that the viewer can also access other management interfaces? So yes, at this time, the dashboards are entirely supported by the DataTorrent RTS, and the visualizations that you were seeing are actually streaming live from you can see all these numbers are changing dynamically. This is all being streamed live from currently running application. If you look at if we look at some other applications here, such as, let's say we take another one, we have a sales dimensions application. This is a good example of actually the earlier question, where a single operator from the logical plan was scaled out into multiple operators in a physical layout. But if we go back to the logical view and we look at visualize, we can see that this demo is also sending live visualization to the dashboards. So yeah, to answer the question, all the dashboards are connected directly to the apps. So you have to have DataTorrent RTS to be able to visualize them. You can certainly take screenshots of visualizations and post static ones, but the interesting and fun thing about these visualizations, of course, is the being able to see the data updating and changing live. That's really what you'd want. So that's all this is being done dynamically. All right. So the last thing that I wanted to cover for this particular presentation was about being able to, because a related question was asked, it was about being able to export and package dashboards. So the dashboards can be exported by downloading them in the JSON format, and they can be packaged with your Apache Apex applications. So let's say you developed a new app, and you want to you can upload it to your cluster, run it, create a new dashboard visualization on the fly, save it by downloading it, and then you can add it to your Apache Apex project by putting it into the sources main resources UI dashboard location. You can just simply, like, let's say we're looking at a Twitter demo dashboard here. We can copy the dashboard into the space. We need to create a descriptor, UI JSON descriptor file, which also goes into the resources UI folder that describes the dashboard and associates various application names that you might want to dynamically link it with. And then you compile your Apex app and upload it. When you've done that, if you go to the visualize area, you'll notice that besides creating new dashboards or uploading existing ones, you can also use import. So the import is for dashboards that have been uploaded through the Apache Apex applications. So you can import them here, but also if you have an application that has an associated dashboard with it, if you go to the develop or the monitor area and look at one of the visualization drop-down buttons, you will, in this case, this application does not have an associated package dashboard. But if it was here, below the list of application dashboards, you would see another section which would be called package dashboards. And by clicking on one of these package dashboards, you can import it directly. So that makes it very convenient for the users to basically work with the dashboards, export, save them, and do other things. So finally, we have some resources available for you for developing your Apex apps and working with the data dashboards and widgets. You can find all the previous webinars and videos recorded on our YouTube channel, and you'll find the slides for this presentation posted as well. And finally, of course, we're hiring, so if you're interested, you can send us your resumes at jobs@datatorrent.com. And finally, we're having Apex Big Data World Summits coming up in Pune on February 10th, if you're in India, or a local one in San Jose, California, on April 4th. So if you're interested in learning more about Apex and big data applications, seeing more exciting demos, including possibly one about going in more depth on visualizations, be sure to join us. You'll be able to find all the relevant information on www.apexbigdata.com. My name is Sasha Parfenov, and thank you for attending this webinar.